Hello grade 7s, Helen here with your latest dose of natural sciences. So what is it that we're going to be learning about today? Well, today we're going to be focusing on the properties of acids. We have learnt about different examples of acids that are all around us in our kitchen, in places where we would not expect to find them, in certain foods, and of course very strong acids found in other places like explosives and to make nitrogen-based fertilizers. We also know that there are certain acids that are present in our own stomach. Things that we would not really consider. Wow, you've got acid inside your stomach. Hydrochloric acid and other dangerous acids like sulfuric acid, hydrochloric acid in pool acid. We know that certain animals contain acids, like ants having formic acid, which is a little bit burny if you were going to eat ants. But common things such as fizzy cold drinks and lots of fruit products all have acids in them. We also have lactic acid in fermented milk products. So now you are at the point where you can identify or recognize certain things as being acidic. But remember what we were doing when we looked at properties of materials. We were looking at characteristics that we could use to describe the material. So when we were looking at characteristics and properties of materials, we were looking at things like durability and strength and boiling point and conductivity. But now we're going to be looking at the properties that acids have. And remember, we're looking at chemical properties. So we can't always see these chemical properties, but we can use the properties to describe the acid. We know, of course, we have learned that acids have high concentrations of hydrogen ions. Now, we can't see the hydrogen ions floating around in an acid, but we can know or recognize the acid from the way it behaves and from other characteristics that we can note. And the first characteristic that we're going to look at when we examine acids is their taste. Acids always have a fairly sour taste. Other words that we can use: a sharp taste, a tangy taste sensation, and sometimes they could even burn your mouth. Now, we're not talking, and I want to warn you again, we're not talking about tasting things like pool acid, which has got hydrochloric acid in it, or the acids from batteries. We're not talking about tasting those dangerous objects and items and materials, but there are certain items and materials that you can and should taste in order to bring to your mind the understanding that acids have a particular taste. And I think one of our most common everyday examples is the acid, the malic acid and fumaric acid that is put on certain sweets, like sour worms, for example. And we know that when you put that first sour worm into your mouth, you kind of get all, wow, that was tangy, that is sharp, that is a real sour tasting worm. And as you start to eat them, that's fine. You get used to it a little more. But have you ever totally pigged out on a whole packet of sour worms? I have. And I'm sad to say that the next day, your mouth feels as if it's been burnt. It feels quite sensitive. Those little papillae on your tongue are actually quite sore. And that is an indication that the acid not only tasted sour, but it can sometimes burn your mouth. Likewise, maybe when you were little, you ate ants, and that formic acid that was present in the ant would have definitely burnt your mouth. It would have felt like a sting to your mouth. You know that certain fruits have quite strong acids in them, and you know that it's not always pleasant to eat something like a lemon, whereas it's more pleasant to have something like an orange, because lemons are more acidic than oranges. And we know that your favorite fizzy drinks also have that sour taste or that sharp burn. Lactic acid in fermented milk products like yogurt also have a sour taste. So the first characteristic that we're going to remember about our acids is that they have a sour taste. Another property of acids is that they are corrosive. Now, corrosive means that if you spill the acid on your hands or on other materials, we can see that the acid will burn away the material. And that is what we mean by corrosive. So strong acids are corrosive. And if you ever see a sign like this one on a substance, then you need to understand that it's warning you that the substance inside the container is corrosive. If it is spilt on your hands, it can hurt you. If it's spilt on other objects, it can eat away those other objects. So when people are working with strong acids in industry or in a chemical laboratory, there are certain safety precautions that they need to take. For example, they will wear gloves. Now, these are not just thin plastic or latex gloves. They're quite hard wearing gloves that will have a rubber component to them, which will make sure that they form some protection against acid spills. You'll notice that people working with these acids have to wear safety goggles because your skin is sensitive to an acid burn, but your eyes are even more exposed in terms of the cells and the damage that can be done if acid gets in your eyes. You usually find that people working with acids are going to have thick laboratory coats over their clothes in case the acid spills on their clothes and will burn holes in the clothing. Although you can't see the scientist, she should be wearing rubber boots. You can't see her feet, but she should be wearing rubber boots in case of spills so that it doesn't hurt her feet or corrode her shoes. Now, we talk about this property of corrosiveness and we talk about these dangerous or very strong acids that have a very high concentration of hydrogen ions in them. Some acids, which we consider to be safe, can also corrode our bodies. So ordinary aspirin that you would take for fairly mild pain contains salicylic acid, and salicylic acid can corrode your stomach lining with long-term use. So you may have seen on the instructions on certain medications that contain acids that you shouldn't have the medication on an empty stomach. You should take it with food. And that means that your stomach lining is not exposed to the acids because it can corrode your stomach lining and it can even produce instances of ulcers and damage to your stomach lining. Now, another property, apart from the sour taste and the corrosiveness, is that when acids are mixed with bases, they neutralize each other. So remember, we said that acids have high concentrations of hydrogen ions and bases have high concentrations of hydroxide ions. Now, when our acids have a party with bases, we find that they neutralize each other. The amount of positive ions is going to equal the amount of negative ions, and we're left with a substance that is a neutral substance, which is not going to burn or corrode in any way. Now, how can that information help you when you are stung by a bee, or eat too much acidic food, or spill pool acid on your hand? We understand that in terms of first aid and safety, if an acid is spilt on someone, or someone comes into contact with an acid, in order to neutralize that acid, they need to use a base. So if you're stung by a bee, which has a bit of formic acid in its sting, along with other substances that cause the pain, but you could try and neutralize the bee sting by using a little bit of soap on the bee sting, which is going to be the base, which then neutralizes the formic acid and helps to relieve some of the sting or burn. What if you eat too much acidic food? What should you do? Well, drinking something or taking a medication called an antacid, meaning opposite to acid, is going to help you and your stomach lining recover from the extra acidity. If you were putting pool acid into your pool and you were not using gloves and you spilt it on your hands, what should you do? Well, immediately you should put it in the water, but if you have burnt your hands, you need to put a cream on it that is basic in nature in order to balance out the acid. Let's see how much you remember of what we've been learning. Cross out the words that are not associated with acids. So let's look at these words. Do we associate sour with acids? Yes. Salty? No. Acids don't tend to be salty. Corrosive? That is definitely a property of acids. They can burn you. Do they feel slippery to touch? No, they tend to feel rough to the touch on our hands because of the burning and corrosive nature. Are acids neutral? No, we don't associate neutrality with acids. Next question, cross out the substances containing acids that are not safe to touch or to taste. Well, lemon juice, we know we put in our food, we can drink, we can eat lemons. That's safe to touch and taste. But pool acid, definitely not. Fertilizer, definitely not. We shouldn't be eating it. We shouldn't be using it on our bare hands. We should be distributing fertilizer with gloves on us. Ascorbic acid, which sounds extremely fierce, but remember, ascorbic acid is simply vitamin C. So yes, that is safe to touch. And lactic acid, which we find in yogurt, for example, and other fermented milk products, that is safe to taste. Why do you think vinegar is used to preserve food by pickling? Well, remember, vinegar is acidic and bacteria do not like acids. So preserving the food in the vinegar will allow the acids of the vinegar to kill any microorganisms such as bacteria. From your experience, last question, do you think chilies contain acids or bases? Well, I think they contain acids because they burn my mouth, and certainly chilies have capsaicin in them, which is a strong acid. That's it for properties of acids today. Goodbye.